Right, I guess we are live now. So maybe just to make sure that everyone has time to join, it usually takes 2-3 minutes to join the broadcast. Welcome everyone for our weekly live stream on Twitch. We're very excited for this live session today with Muhammad, who joined us today to talk about the CLC user experience with using Kafka and
Mhm.
real-time stream processing. So welcome, Muhammad. How are you today?
Thank you. I'm pretty good. What about you?
Yes, good. Excited to have you here on Twitch. It took us some time to prepare. So perhaps we make a little bit introduction about your background and when you joined Hazelcast, what you're working on.
Yeah. All right. I started working at Hazelcast about 2.5 years ago. My first team was the integration team. The team worked on integrating Hazelcast into other platforms and systems. And then the team was transformed into the cloud native team. And there I've worked on mostly about Helm charts, Hazelcast discovery plugins, and the platform operator. And since last month, I've been working on CLC. So I'm here to show you a demo about the real-time stream processing and managing it with CLC.
That's great. I think we had a session before on CLC. So usually did that session. It was really good to see how easy it is to use CLC. So I'm looking
Yeah.
forward to this as well. And since you mentioned Kafka and real-time stream processing, I just like to share a few links. So for anyone now is watching us on Twitch or later on YouTube, we have a dedicated blog post here on how you can enrich Kafka applications with contextual data. So feel free to go through this blog post. And next week, we are very excited to be back at Kafka Summit London. So we have a registration page as well. So feel free to go there, sign up with your details, and let's have a chat about your Kafka pipelines and how you can take it to the next level. And if you are in London, we also have an event with the London Java community. So this is like a beer craft and dinner with Hazelcast and London Java community. So make sure also to sign up for this event. And we look forward to seeing you next week in London. So with that being out of the way, so I will hand it over to you, Muhammad. So to take it over. For anyone watching us live now, so feel free to leave your questions in the chat box. I will take this question and send it to Muhammad as we go along. Over to you, Muhammad.
All right. Thank you. I'll share the screen. Right. So you should be able to see it, right?
Yes.
All right. So our demo topic is creating and managing real-time Kafka pipelines with Hazelcast CLC. First, I'll talk about what CLC is and why is it easy to use and why is it easy to use and interact with Hazelcast clusters. So CLC is a lightweight command line client written in Go. It is a single binary with no dependencies, so it's very easy to install on your platforms. Right now, you can install it on Linux, Mac OS, and Windows operating systems, and we also have an installer for Windows. It supports SQL, JET, which what enables Hazelcast to do stream processing, and data structure manipulation commands. Right now in CLC, we support the map, but in future we can add more data structures. If you have any suggestions, you can contact us in the community Slack channel. We'd love to hear your feedback. It can be called as a one-shot command or it can be run in interactive mode. So in one-shot command, you just run a command and get the result. So it's it can be integrated into CI/CD pipelines. And for the interactive mode, you can run multiple commands one after another. And it's very easy to use with SQL because interactive mode has a syntax highlighting for SQL. And you can run other CLC commands in interactive mode by just perpending a backslash to them. CLC connects as a client to the cluster, so it follows the enterprise security ACLs. It has low friction configuration, and it can connect to any cluster, whether it be local, remote, or Hazelcast reading clusters, which are running on the cloud. It's very easy to switch between the clusters and create configurations. So you can create multiple configurations for your different Hazelcast clusters and switch between them by just changing the flag. I'll show you how it's done when I start the demo. So we can now go over our architecture overview for the demo. So in the picture, in the diagram, we see that we have this JET pipeline, and it receives items from the Kafka with the topic named orders. So the orders holds the information about the desserts, dessert orders. The JET receives these items in a stream, and then it enriches the orders using the desserts map, which is the Hazelcast IMAP. So it gets the orders and gets the desserts. This gets a map from the desserts map, and then it enriches the order, and it finally produces a result, which is the enriched order, and then it puts the result into a new Hazelcast map, which is named orders. What CLC does is CLC lets you manage your JET pipelines, create and manage your JET pipelines through the command line. And it's very easy to use, and we'll see it in action when we start the demo. So we can probably start with the demo, but before starting, if you want, you can follow along with the demo. You can use this QR code, so I'll wait a few seconds here. And we have the demo in the GitHub repository, so if you want to check out, you can check out the demo after or during the demo. So I'll go over with the demo, but before going with the demo, I want to show you which Hazelcast and CLC versions we are using, because JetJob submission support with the clients was added in Hazelcast 5.3.0, and it's not released yet. We are using the latest beta versions. So in the demo, I'll use Hazelcast 5.3.0 beta 2, and for command line client, I'll use the latest beta version, which is 5.3.0 beta 1. You can download the command line CLC here on your platform very easily. So now I think I can start with the demo. So before starting, I want to say that I have a local Hazelcast cluster running, and I have a Kafka broker. So let's start running some CLC commands and see what we can do with that. So first command I want to run is help, and see what commands we support. So as I said before,
if it is possible, please, can you just enlarge the font size, please?
Yeah, sure. Yep.
Thank you.
Yeah, okay. Now you should be able to see. We have distributed data structures. We have JET comments, SQL comments, Viridian, and additional comments. Because we want to connect to the cluster, what we want to do is we want to create a config. So let's check the config comment. We want to add a config, so I'll just add a config with name local, and I can list the configs here, config list. So I only have a config which is named local, and to use the config, you just give a -c and the config's name. So now the CLC will connect to that cluster, and I just want to see that if I have any object in that cluster. And let's see that we have no object. Next, what I want to talk about is the SQL support for CLC, and I have a sample CLC file. for the demo, in that SQL file, we have these DDL comments. The first command is, it creates a mapping named desserts. Its type is IMAP, so it creates a map, and the map has the name and category fields. These options are used for serialization and deserialization of the items of the map. The second is the orders. This is the enriched orders that the JET pipeline finally writes to. So we have the dessert ID, which points to the dessert in the desserts map. We have the item count, and we have the dessert's name and dessert category, which are strings. And these are the actual enriched fields. The next command is the sync into. This is the same as insert into, so we are inserting some values into the desserts map. So we have 53 values. So let's actually run this command on the cluster. I'll pipe this file into CLC, and I will give the config, local config. So now it should run these SQL commands on the cluster, and we can check it. What I'll do is I'll start a shell mode, and now I can run SQL queries on the cluster, and I can also run normal CLC commands by appending a backslash, and we can see what commands it supports, and it's the same as the normal ones. So I'll check the size of the desserts map, which we just created and inserted some values. So the size of the desserts map is, it should be 53, and it's 53. And we can also check the check how many items we have in each category. So I'll write an SQL query. Let's select category and count all as total from desserts. We'll group by category and order by total. And now we see that we have 9 cakes, and most of the categories have 5 items, and hot beverages has 4. Now we can go to the JET pipeline code and see how it's constructed. First, let's look at the data classes we have. We have this order class, which represents the items coming from the Kafka topic. So we have the dessert ID and the item count, which are integers. We have this dessert class, which represents the items in the map. It has a name and the category, and as you see, category is integer. So there is an error here, but when we compile the project, we won't see any errors, but we will see the error in the running time on the cluster and see how we can find the error and solve it. And the last is the enrich order, which calls the order with the enriched fields. So we still have the dessert ID and item count, but now we also have dessert name in the category. And as you see, the category is integer here too. Now we can go over the main function and see what it does. First, we have the properties for the Kafka consumer, and then we create the pipeline. So how we create the pipeline first reads from the Kafka source, which receives items from the orders topic. And what it does is it enriches the order with the desserts coming from the desserts map. How it does is it gets the order and it finds the order's dessert ID, and then it gets the desserts JSON using the dessert ID from the desserts map, and then it enriches the order using the order and the dessert JSON using this function. And what this function does is it creates the order and the dessert object from the JSON. And it creates a new enriched order object, and it creates a new pair. This code is written in Kotlin, so if it's not familiar with you, it's because of that. So we are creating a new pair. The pair's first item is the orders key, and the second item is the enriched order. After this step, what we do is basically write the result into a map. This map is the orders map, and we add a key and value. The first item is the orders key, and the second item is the enriched order. So we can actually build the project, but before building, I want to go over the build.gradle file. So because this project has some dependencies, and the dependencies are not in the Hazelcast cluster, we are building an Uber jar so that when we submit the jet job into the cluster, it has access to those jars. And we don't add the implementation for Hazelcast and Hazelcast check Kafka because they are already present in the Hazelcast cluster. So now we went over the code. We can build the jar by just running the make build command. So we'll wait a few seconds. While it's building, we can check the job comments. So, okay, now it's built. CLC job help, and we can see the job comments. The first command we will use is the submit. After submitting, you can suspend the job, which then you can resume. You can restart a running job, or you can cancel a running job, and you can list the jobs you have. And exporting a snapshot is an enterprise feature. It creates a snapshot in the Hazelcast cluster for that job. It holds the metadata for the job, and then you can create new jobs from that snapshot. You can also run export snapshot with the reading clusters. So let's first run the submit command. CLC. So let's give the configuration and then job submit, and then see what are the parameters. So we will just give the jar file, and we can also give a name, and then we'll also wait for the job to get into the running state. All right, so let's give the jar's path, and then the name of the job will be job 1, and we'll wait for the job to get into the running state. So we can probably run this command now. So the jar is now in the running state. Let's list the jobs we have. All right, it's in running state. I'll also, in the meantime, I'll create a new, I'll run a new command to see the orders map changing in the time in parallel. So this will wait 2 seconds. Every 2 seconds, it will run this command. So it will run map size. So it will find the size of the orders map every 2 seconds. Right now, you see that it's not changing because we don't have any producer, and we have a producer program, which is a very easy Python program. What it does is it gets the desserts from the cluster, and it creates random desserts, random orders, and it sends it to the broker. So I'll run this command here. So Python 3 producer main.py. Let's see. Yep, it's in. Now it's producing, but now we don't see any change in the orders because the job actually failed. Why did it fail? Because as you remember, we gave some wrong fields in the data classes. So we can actually check the error here. It's a very long error because it's Java, but we can probably find the reason for the error here. Cannot deserialize value of type int from strings, and the clusters is a category. So we can go back and fix it. Let's go back and fix the code. So we will change it to the string. We'll also change this one to the string. Because the job is failed, it's not running anymore, we will create a new job. So we should first build the jar again with the fixed code, and then we can submit a new job. So this job will be job 2. Nothing needs to be changed. And now you see that the item count jumped to the 75, and now it's increasing 2 by every 2 seconds because we're producing 1 item per second. Maybe let's check the items in the map, orders map. So I'll map entry sets, and the output form will be table. And I should actually give the map's name because right now it ran on the default map, and the order map will be the orders. And as you see, we have items created. It has the category and the name, which are the enriched fields, and we have the dessert ID and item count. So now we can suspend the jobs and see if it actually works. So let's check the job comments again. It's just suspend, and we can also list the jobs. All right, so we have the ID and the name, and while suspending, we can use both of them, either of them. So I will use the name because it's easier. So I will suspend the job 2. Yes. And now we can see that the orders map size is 161. It's the same, it's not changing. And when we start the job, it should jump to a new number because the producer is still producing some results. So I will resume the job. Okay, let's resume it. It jumped to 193, and it's increasing. So we can list the jobs and see that it's in the running state. We can cancel this job, or before that, we can create a snapshot. As I said, creating a snapshot is an enterprise feature. And right now I have a enterprise cluster running on my local, so I can run the export snapshot command. But first, let's see how that command is run. It's export snapshot, and I'll run help and see what it does. Okay, so I will give a name and the job's name. So job's name is job 2. I will export this job, and I will create a snapshot named snapshot 1. Now it's created. Let's check the snapshot list. Now we can see the snapshot. So now we can cancel the job. Local job cancel job 2. Yep. The job is canceled. And the snapshot holds the metadata about the job. And we can create jobs using that metadata. We can also delete that snapshot later when we create new jobs. Maybe just let's do it. I'll just create the job now from the snapshot, but for that one, I'll check the command again, job submit command, and how to see how I can give a snapshot. So I'll just give a snapshot. So let's find submit comment. I'll submit a new job, which is job 3. And I will give a snapshot, and the snapshot will be snapshot 1. So it will use that snapshot to create the job. Let's run it. As you see, it's again jumped to the 330, and now it's increasing again. We can list the jobs. So we have this running, and we have this failed job here again, and the other canceled job is gone. This is because the other job was canceled by the user, so it's not shown here. But this job is here because it's failed on the cluster because of the code, not because of the user. And if we run help, we can actually see that include user canceled parameter. If we give that, we will see that job 2 should be there. And as you see, it's actually there. So lastly, we should cancel the last job and then delete the snapshot, and the demo should be over. So I'll delete the last job, cancel, job 3. I canceled it, and now I'll delete the snapshot. Local snapshots, delete snapshot 1. It's also deleted. Let's test the snapshot. It's not there, and let's test the jobs and see if there's anything. So we only have the job 1, which was failed because the code was wrong. Yep, this is it for the demo. We can go with the questions if you guys have any. I don't hear you because it's muted.
Yeah, so this is really cool, Muhammad. Thanks very much. I really would like to try it out after we finish this Twitch stream. So it will be great for everyone to try out the CLC. Give us your feedback. There is a documentation that you can follow. It's on the screen. Take screenshot. You can basically install Hazelcast, try the CLC, and there is a form that you can fill in just to give us some feedback on the CLC, or you can also create a free account on our Viridian cloud, and then you can also scan this QR code for our community Slack, where we're happy to answer any question you may have. So we got a few questions for you, Muhammad, if that's okay with you.
Yeah, sure.
So first question is, does the CLC work only with maps?
Right now, as a data structure, right?
Yeah.
Yep. So CLC right now only has support for the map operations and generic distributed data structure operations, as you see. So if we run objects help, we can see that it only lists the object. So yes, we can say that right now we only support the map operations, but if you have any suggestions, you can send them, right?
Sure. And can we use languages other than Kotlin or Java?
For pipelines, I think you can use Python too, because there is a support. I'm not really familiar with that because I'm fairly new, but yes, you can also use Python to create pipelines. Yeah.
Okay. And the other question is, do we need to specify config for all commands, or can we use default config?
That's a good idea. Right now, if you run the command as a one-shot, you should, or you must give a config parameter. But if you run it in the shell, you don't have to give it. You can run the commands in the shell without the, as you saw, without the configuration. But yes, that might be a good idea actually, to have a default config so that you don't have to give that every time you run a command.
So here you go. One good feedback here.
Yeah.
So can we rerun the failed job instead of submitting a new one?
So that job is failed, so you cannot run it, because you cannot cancel it also. So you have to give a new job for the failed job, and it will be garbage collected later.
Okay, and the other question is it possible to use the CLC with Viridian?
It is possible to use it with Viridian. Yes, you can run all these commands on the Viridian also, but the jet job submission, I'm not sure what version is Viridian is on now, but if the Viridian version is 5.3.0 or above, you can do the same things I did in the demo on the Viridian clusters.
Yeah, so the whole idea basically of using CLC is to provide better user experience and developer experience. So definitely, if it's not currently available with Viridian, it's on the plan basically, and we will let you know if you can join our Slack community. There is a dedicated channel for CLC, so you can also ask questions or over there. Is it possible just to go back to the main figure for the demo?
Sure.
Basically,
Yeah.
where we have.
Mm-hmm.
So essentially, we had the Kafka topic, and we have the orders coming from Kafka topic. And then we used the JET pipeline to enrich the data from the desert's IMAP and then create a new map with the contextual data. So is that correct here?
Yes, that's correct. And the pipeline is simple here for purpose, but as you know, you can make complex pipelines with JET and do much more.
So yeah, so speaking about languages, I'm not sure if the languages question was to talk about the JET pipeline or the CLC. So I'm happy to basically answer this question. If you can leave us a comment here, just to clarify this question.
Okay.
Yeah,
Okay, I
because
thought
it's
it
not
was
clear
about
if it is
JET.
meant for CLC or for the JET pipelines. Okay, so with that being said, I think so the question was mainly for JET pipeline. So if you want to use the JET pipeline, essentially, you need to create a jar basically for it, and then you can submit this jar to Hazelcast. So with CLC, you can use it. So CLC is not dependent on the programming language, if that makes sense.
Yeah. CLC is not language dependent. It's a command line tool, so it's
So that's really great to hear about this demo. I'm looking forward to try it out and see what is possible to do with the CLC. So thanks very much, Muhammad, for your time and for this demo.
Thank you as well.
I will make sure to export this live stream to Twitch. And if people wants to try it out, here is the QR code. So you should be able to download it directly. So perhaps, Muhammad, after we finish, if you can post this demo onto the CLC community Slack channel.
Okay,
so,
I'll share the demos link. Yeah, repository
and
link.
I look forward to speaking to you again with the new features coming to CLC. Thank you.
All right, thank you as well.
Thanks, everyone.
Bye-bye.